Hello, everyone. Thank you for joining us in this session of Spokane Public Schools Keep Learning series for mathematics. Today's session is for students in grade 5, but all of you are welcome to join in. My name is Mrs. Leonard, and I'm a mathematics instructional coach at Logan Elementary in Spokane Public Schools. I'll be your teacher for this lesson, and I'm so glad you're participating with me today. Today we'll be applying what we've learned about fractions to solving real-world problems. For today's lesson, you'll need paper and pencil. You might also find colored pencils or crayons helpful. I'll give you a moment to gather your supplies. Let's get started with a number string. I'll be using an area model to help us visualize the mathematics. Brain research has shown us that our brains learn better when we can represent math with visual models. So even if you found a shortcut to solving problems involving fraction multiplication, we still want you to be able to think about it visually to deepen your understanding. Let's do the first problem together. I'll be using a free GeoBoard app from Math Learning Center. If you want to try out this app after we're finished with our lesson today, go to apps.mathlearningcenter.org/GeoBoard. However, you don't need this for today's lesson. Just use your paper and pencil. Here's our first problem. 1/5 times 1/6. I already built an array that would work well with fifths and sixths. Can you see the fifths represented by the horizontal rows and the sixths represented by vertical columns? When I read the expression 1/5 times 1/6, I like to think of it as 1/5 of 1/6. So I think I'll represent 1/6 on the GeoBoard first. The red rectangle represents 1/6 of the large rectangle. Now I'll represent 1/5 with a different color. The blue rectangle represents 1/5 of the entire pan. The overlapping portion creates a purplish color. That portion represents the 1/5 of 1/6 that we're looking for. What fractional amount of the whole pan is that? I see that just one square is shaded out of the entire 5x6 rectangle. 5 times 6 equals 30, so it's 1 out of 30, or 1/30th of the entire pan. Last time we met, we noticed that the dimensions of the small rectangle match our numerators, while the large rectangle matches our denominators. Some of you noticed that you could just multiply the numerators, 1 times 1, and then multiply your denominators, 5 times 6. Using a visual model really helps us understand why this works. Here's our next problem. Try this one on your own, then we'll talk about it in a moment. 2/5 times 5/6. Remember to sketch the model and find the product. Great job, everyone! You are really getting great at multiplying fractions. Here's what I think many of you did. First, you started with an array that could represent both fifths and sixths, so you drew a 5x6 array. Then, you shaded 5/6 of the rectangle. Next, you shaded in 2/5 of the large rectangle. The overlapping purplish area represents 2/5 of 5/6. That's 10 out of the 30 squares, or 10/30ths. We can see how the numerators create a 2x5 rectangle inside the larger 5x6 rectangle created by the denominators. We can also see this in our equation. 2 times 5 equals 10, and 5 times 6 equals 30. Can you simplify 10/30ths? If we take the purple rectangle and rotate it, it might help us. Now we can see that the purple rectangle represents 2/6 of the entire rectangle. We can also see how 3 of these purple rectangles fill the entire large rectangle, so we can simplify it further and name this fractional amount as 1/3. Some of you may have simplified using a fractional whole. We know that 10 is a factor of both the numerator 10 and the denominator 30, so we can divide 10/30ths by 10/10. 10/10ths is just another name for 1 whole. We know that any number divided by 1 equals that same number. So, when we divide 10/30ths by 10/10ths, our quotient will be equivalent to that first fraction. 10 divided by 10 equals 1. 30 divided by 10 equals 3. So 10/30ths is equivalent to 1/3. Nice work, everyone. You're really doing a nice job multiplying 2 fractions. But what happens if one of our factors is a mixed number? Let's think about 1/3 of 1 and 2/5. I'll use an area model to help us visualize what this means. I drew 2 3x5 rectangles to represent our whole. Then I shaded 1 and 2/5. Next, I shaded in 1/3 with red. The overlapping portion makes an orangish color. We can see that 1/3 of the first whole is 1/3. In the second rectangle, we can see that 1/3 of 2/5 is 2/15. Now we just need to add these together. We haven't done any fraction addition recently, so let's think about this. What is something important to remember when adding fractions? I'm remembering that adding fractions becomes much easier if we have the same denominator for each fraction. 15ths would be a nice common denominator. I'll need to find an equivalent fraction for 1/3 with 15 as the new denominator. I can multiply 1/3 by the fractional whole of 5/5. So if I multiply the numerator of 1 by 5, I get 5. And then I multiply the denominator of 3 by 5, and I'll get 15. So the new equivalent fraction for 1/3 is 5/15. Now I can add 5/15 and 2/15. What sum will we get? Remember, the denominator stays the same when we add. Did you get an answer of 7/15? Let's go back to our model and see if that makes sense. See how there are 7 of the overlapping orangish squares? And see how there are 15 squares in one whole rectangle? So there we can see 7 out of 15 squares in a whole, or 7/15 of the model is shaded that orangish color. So visualizing really helps me understand my answer and make sure it makes sense. Now try this one. 2/3 times 1 and 1/4. Remember to sketch the model and find the product. Think about the size of the rectangle that you'll draw. Then shade in the fractional amounts to find a product. Write an equation to match. If you can, simplify the fraction. Do this work using a model that makes sense to you. How'd it go? If you need more time, don't worry. You can finish this one after this presentation. This would be a great opportunity to show your classroom teacher what you're learning about multiplying fractions and mixed numbers. Just take a picture of your work and send it to your teacher. Also, remember you can always reach out to your classroom teacher if you need additional support multiplying fractions and mixed numbers. Now let's switch gears a bit and start solving some problems in context. In a previous lesson, we talked about fraction multiplication problems in the context of a pan of brownies or a tray of cupcakes. But real-world problems that require multiplication come in many forms, and they're all around us. We'll solve a few of these today. Here's our first one. Jamie has 3/4 of a liter of juice, and she's sharing it with her friends. Together, they drank half of the juice. How much juice, in liters, did they drink? The important mathematical information in this story is that there was 3/4 of a liter of juice, and they drank half of it. So we're trying to figure out half of 3/4. Can you think of an expression to represent this information? How about 1/2 times 3/4? Take a moment to solve this problem. Use a strategy that makes sense to you. How did it go? I know there were many wonderful strategies being used, and I wish we had a way that you could share them with all of us. But since we don't, I'll have to imagine what you might have done. There are lots of ways you could have solved this problem. Maybe you used an area model like we did in our number string. If you did, maybe it looked something like this. I can see 3 overlapping squares out of 8 squares in the whole rectangle. So Jamie and her friends drank 3/8 of the liter of juice. Maybe you visualized a carton of juice and thought about what half of the 3/4 carton would be. If I did this, I might have thought about finding an equivalent fraction for 3/4 that would be easier to split in half. How about 6/8? Half of 6/8 is 3/8. Or maybe you thought about the shortcut of multiplying the numerators than the denominators. 1 times 3 equals 3, and 2 times 4 equals 8, so 3/8. Maybe you even did something different than those strategies. That's great too. I love when we solve a problem using a variety of strategies. The different models can really help us see why for this problem, 3/8 of a liter of juice is the correct answer. Let's try a new context. George and his mom decided to go for a hike. The total distance was 3 3/4 miles. They decided to stop 2/3 of the way to have a snack. When they stopped to have their snack, how far had they walked? Can you pick out the important information in this math story? What expression could you write to match this story? I thought of 2/3 of 3 3/4 mile, or 2/3 times 3 3/4. Take a moment to solve this problem. I'm so interested in how you will solve a problem that includes a mixed number. You may not have enough time to finish the entire problem now, but at least get started, and then we'll talk about it. Did you get a good start? I'm guessing that this one feels a bit more challenging. Multiplying with mixed numbers does add a couple more things to think about, but I know you can do it. Did the area model help you? I drew 4 rectangles, then shaded in 3 3/4 with a light yellow color. Next, I shaded in 2/3 across all of the rectangles with another color. The double shaded area represents how far George and his mom walked when they stopped for a snack. I count 30 of these double-shaded squares. There are 12 small squares in each whole rectangle, so 30 out of 12, or 30/12 miles, is the distance they had walked when they stopped for lunch. We can simplify 30/12. I notice both numbers in this fraction are divisible by 6, so I can divide by 6/6. 30 divided by 6 is 5, so that's our numerator. 12 divided by 6 is 2, so that's our denominator. So 5/2 is our new equivalent fraction. Let's turn this fraction into a mixed number so we can understand the distance a little better. We know fractions represent division, so we can think of 5/2 as 5 divided by 2. If I work that out, I get 2.5. So George and his mom stopped for a snack after walking 2.5 miles. That makes sense in the story, since they would have stopped before they walked the entire 3 3/4 miles. Perhaps instead you thought about this one as length instead of area. That works too. There are many visual models that we can use to represent our work with fractions. Here's a problem for you to try on your own. Marcus is making his costume for the school play. He cut a piece of fabric that was 1/3 of a yard by 3/8 of a yard. What is the total area of that piece of fabric? Take some time to jot down the important mathematical ideas from this problem. When this session is over, take some time to solve the problem. Use a model to help you visualize your thinking, and then write an equation with the solution to the problem. If you have questions about fraction multiplication, your teacher can help you. Also, your teacher would really like to see your mathematical learning, so take a picture of your work from today and send it their way. Today we solved real-world fraction multiplication problems in many different contexts. You're probably using fraction multiplication often in your daily life in many other ways. I have a challenge for you. Come up with a new story problem that requires fraction multiplication to solve it. Then, find the solution. Send your story to your teacher. Who knows, maybe you'll see the math story that you created in some of your future homework. I've enjoyed doing some mathematics with you today. If you're looking for more activities, they can be found on the Spokane Public Schools Learning from Home website. Thanks so much for joining me as you continue your learning from home. I look forward to seeing you again for our next lesson on KSPS.